Hello everyone, welcome to Clean Coder YouTube channel. So today we are going to solve problem number 1302, deepest leaves sum. This is a lead code medium level problem. So I'll go through the problem statement quickly. It says given the root of a binary tree, return the sum of values of its deepest leaves. Okay, so this is the binary tree given to us, and its deepest leaves intuitively are 7 and 8. So the answer which it is expecting is will return 7 plus 8, which is 15. So example 2 is easy. Also you can try to trace it out on your own. Constraints are also quite trivial. So let's move to our whiteboard and analyze the different approaches. Okay, so I would say mainly there are kind of two approaches possible. First one is recursive using DFS approach. So there is a separate video in which I have explained in depth the recursive approach for solving this problem. So if you haven't watched that video, I would highly recommend you to please go through that. The link would be most probably in the comment section of this video. So in this particular tutorial, we are going to talk only about the iterative solution. Okay, we are only going to talk about iterative solution. So let's see the example which they have given to us. So this was the tree, so its deepest level was this. So the answer was 7 plus 8 equal to 15. So if the tree they would have given us would have been something like this. Okay, so its deepest level would have been this. Okay, so the answer in that case would have been 4 plus 5, that would be 9. So the problem is quite straightforward. Let's have a look at the algorithm which should help us solve this problem iteratively. So this is our algorithm. This is like actually I have written the level order traversal modified in the words form. So let's go through this simple algorithm really quickly. It says we are going to use a queue data structure, and we are going to try to differentiate the different levels of binary tree with null separator. Okay, what it means is that we are basically in the queue adding the null separator wherever levels are changing. So like this null separation trick really helps in simplifying the code, and with the like not much effort we are able to differentiate the different levels of the binary tree. So it is just talking about that, and what it says in green, it says store the sum of the last level nodes only. Okay, so there would be first level nodes here, and then null separator. This would be second level nodes here, then null separator. This would be third level nodes, and similarly there would be last level nodes. So whatever are the last level nodes, we are going to store the sum of that only, and we are going to return that sum. So don't worry like if you haven't completely understood the algorithm, because we'll be doing the complete code walkthrough. So let's move to the code walkthrough part really quickly now. Okay, so there's the code like I've written to solve this problem iteratively. So let's see what this code does. I'll go through the code line by line, and parallelly I'll try to execute this code on this test case, and we are going to compare like whether we are able to obtain the answer 5 or not. So let's get started. So this is our function deepest leave sum, and this is the root of the binary tree given to us. So if a null binary tree is passed to us, then the answer is quite straightforward, and we are returning 0 in that case. So the next base condition is like if a tree with a single node is passed to us, then again answer is quite straightforward. Whatever that node contains value, the answer is going to be that, so we are going to return that. So if these two conditions are false, then it means the tree is something like this or this, right? So let's check the rest of the level or traversal code. So what we are going to do is we are taking a queue of nodes, okay, queue, and in Java queue is an interface. So if we want to assign a concrete class out of it, we are going to use a linked list for that. Okay, then what we are going to do is we are going to add root to our queue and also parallelly adding a null. Okay, so if this is the test case, what would be the change? This is my queue, so I'm adding a 1 and I'm adding a null. Okay, the queue would look like this. So what are the two variables? Sum and res is 0, so I'll make these two variables as 0. Okay, let's move forward in the algorithm. So tree node queue dot poll. So what is poll? Poll is nothing but poll plus peak. Okay, so poll is nothing but pop plus peak. So node would point to this node 1, the head of the queue, so it is pointing to this. Okay, so what I'm going to do is I'm going to increment the sum with this node's value. So sum is now going to be 1, and we are going to check the nodes.left's value. So if the left node of this exists, then we are going to add that to queue 2, and similarly if right node exists, we are going to add that to queue. Okay, so now it will proceed towards the next iteration of the binary tree, and I'll remove 1 from this. Now what would happen is I'll again poll from queue, and now I'll point to null. Okay, so my node would be null, so I'll enter this else clause. So what else clause would do is it will save this level sum. Okay, this level sum is 1, and it will save this level sum to res. Okay, result. So this would become 1 and sum would again become 0. Okay, so this is the latest copy of like the sum of the nodes at the level till which level or traversal has processed. So that is stored in res. So if queue is not empty actually till here, what it'll do is it will add a null at the end. Okay, so like this null would be added, and I'll remove this now. Okay, so now the next iteration would happen, and I'll point to 2, which is this. Okay, so node is not null. I'll enter this if block. So sum plus node dot value. So sum would be 2 now. Okay, so 2's left doesn't exist, 2's right doesn't exist, so this would just move out of this. I'll remove the 2. Okay, now we are going to go towards the next iteration of the while loop. So where it would point to 3. Okay, again it will add 3 to this 2, and it will become 5. Okay, so 3's left doesn't exist, 3's right doesn't exist, so nothing much here, and I'll remove this 3 from the queue. So till here the algorithm is now only null value is present in the queue. So in the next iteration, even this null value gets popped from the queue. Okay, now my queue is empty and node is null. Okay, so I'll enter this. First what it will do is it will save the partial level sum to result. So it will save this 5 here and it will itself become 0. Okay, now partial sum is 5 and now queue is empty, so this won't execute. Okay, queue is empty, so this won't execute. Now in the next iteration of the while loop, when it will check is queue empty, yes, queue is empty, so it will come out of the while loop and it will return the result. So result in this case is nothing but 5 and these two values are same, and it means our algorithm is working correctly. So this was all I wanted to talk about code walkthrough. So now let's quickly compare the time and space complexity. So time complexity is pretty straightforward. We are going to do a single pass of the binary tree, so it is nothing but of n. And what space complexity is? Space complexity is big O of w, where w is the width of the binary tree. So more dense the binary tree, greater would be its space complexity. So this was all I wanted to talk about the iterative solution in this video. So if you liked my code walkthrough and if this helped you in better understanding, please consider subscribing this channel. It takes a lot of effort to make videos, so I just want like you to please at least subscribe my channel, and it would serve as a big motivation for me. So once again, thanks a lot for watching.